In class, you've been exploring a number of rules having to do with logarithms. I'm just using the shorthand log of a PQP rule, and that just stands for the product rule, the quotient rule, and the power rule. You'll remember that when we looked at exponents, there were certain rules that applied in terms of when we had a to the x times a to the y. That was a times xy. When we had a to the x over a to the y, was ax minus y. And when we had the power, a to the x to the power of y, it was a to the xy. And you'll see here that there are connections here, that when I'm multiplying within a logarithmic function, I can separate them by addition. So multiplying, oops, sorry, I have a tiny error here. This should be x plus y. Excuse me. Hopefully you guys caught that before I did. So when I have the two bases being multiplied, I add the exponents. So being multiplied, I add. Being subtracted, I divide. Divide, subtract. Being raised to a power, I multiply. I multiply. So that there's an analogous relationship between logs and exponents, which we should expect given, again, that these are inverse functions of each other. So let's look at a couple of examples. First example, log base 4 of 10ab squared. So what they're asking me to do here is they're going to ask me to expand this out. I want it to be written out as long as humanly possible. So the first thing I'm going to do is I'm going to move this 2, and that's the power rule. So the 2 moves to the front. And then I have the product rule. I have 10 times a times b, which now means I'm going to expand that out to say 2 log base 4 of 10, 2 log base 4 of a, and 2 log base 4 of b. Second example, log base 6 of 20 over x. This is my quotient rule. So I separate it out as log base 6 of 20 minus log base 6 of x. Now sometimes they're going to want me to go the other way. So if I have log base 10 of 4 plus log base 10 of 8 minus log base 10 of 2, I would rewrite that as 1 log base 10 of 4 times 8 divided by 2, which I can simplify. So log base 10, 32 divided by 2 is 16. One other kind of problem, kind of example that your book is having you do and that your teacher is having you do is when they tell you something like this. They'll tell you that log base 2 of 3 is approximately 1.585 and log base 2 of 7 is approximately 2.807. And then they'll ask you to simplify log base 2 of 21. Now, I can rewrite log base 2 of 21 to be log base 2 of 3 times 7, which means I can rewrite that as log base 2 of 3 plus log base 2 of 7. They gave me, the calculator can do this, and you'll learn that at some point, but they gave me in the book these values so that I can replace log base 2 of 3 with its approximate value of 1.585 and log base 2 of 7 with its approximate value of 2.07. And then I add those two values. So 1.585 plus 2.807 gives me an approximate value of 4.392. Remember, these are approximates because there is no exact number that when raised to a power, there's no exact power that's going to give me 2 to that power equaling exactly 21. So my x is going to be an approximate value, and in this case it's approximately 4.392.